So let's look at question 3 from the National 5 2014 physics paper. This is quite a tricky question to get correct. Really need to understand the rules for current and voltage in series and parallel circuits. Although in this case really it relates to current alone. So what have we got? A student suspects that ammeter A may be inaccurate. That's ammeter A1. So you can see in every circuit there are two ammeters. Ammeter A2 is known to be accurate. Which of the following circuits should be used to compare the readings on ammeter A1 and A2? I suppose the way you're thinking about this is that you want to get a circuit where both ammeters are going to give the same value. So let's go down through the list of circuits and we'll see which ones we believe would give the same value. So in circuit number 1, we have ammeter 1 and 2 in parallel. So current leaving the battery would travel down through the circuit at this point here. Some of it would enter resistor 1 and the rest would then travel down and enter resistor 2. If these two resistors are different, then the readings on the ammeters are going to be different. So there's no way of knowing actually if ammeter A1 is correct there. So that one's no use. Let's move on to part B. Current again flows down here, leaves the battery, flows through ammeter 1, goes all the way around, and flows through ammeter 2. Now the readings on ammeter 1 and ammeter 2 in this case should be identical because the current is the same at every point in the circuit. And so if ammeter 2 is correct and ammeter 1 says a different value, then we would know that ammeter 1 is inaccurate. So definitely B is the correct answer. But just for completeness, what we'll do is we'll just quickly skim down through the rest of them and just check that as well. So C and D. In question C, we've got a bit of a weird one here because we've got an ammeter across the voltage supply. Now, one thing that you may not know about an ammeter is an ammeter has got zero resistance, and so current will flow through the ammeter, and so effectively this is like putting a short circuit across the battery, and so all the current will flow through here, nothing will flow through here, and so these two ammeters will not give the same reading. So that's not going to be any use. And what about D? Well, again, current leaves the battery and the current entering the battery will be the same value, and that will be the largest current, but then that splits as it goes through resistor R1 and then resistor R2. So A2 will have a smaller current than A1 will. So in this case, we can't compare these. They're not going to give the same value. And then finally, if we move down to E, again we've got an ammeter across the supply voltage, and so that's going to short out the battery. All the current's going to flow through here around in this loop, and there's going to be no current traveling down to these resistors. So these two ammeters are going to give different values. So just to clarify then, the right answer is in this case B, and that's because ammeter A1 and A2 are both giving the same value.